recorded.
This is not the first time. They've been recording the lectures for a while now. Okay, so let me screen share. So you guys have the screen share, I take it, right?
Yeah, I can see it.
Okay, the first thing that I want to do for an introduction is the box, because the box is kind of where everything is centered. And so you just have to go to the Baylor box right here. You all have access to it. It's like automatic access. And you have to sign in. And then you'll have this, we share this file called the Stata course. And in that course is going to have all of the material you really need. You have to actually download the program, Stata, which you guys are doing, but the databases are here, which you can get off the box. These are the two major databases that we use. And the lecture that I'm going to give, I thought was here, but let's see. I didn't add it yet. Let's see.
Okay, Caroline's here too.
Okay, awesome.
Yeah, sorry about that. I was out running an errand when I got the email.
Oh, okay, no problem, no problem. Let me go ahead and pull this up. I didn't have it in the box. So the box has sort of a lot of things, and we'll just go over it briefly, and I'll give you sort of the introductory presentation that I do. But if you go to, this is the course from 2018. We've been doing this course, or I've been doing this course for, I think this is my 4th year of doing the course. So we've got people that we've been training for 4 years now, probably around 50 kids, I'd say, between 40 and 50 kids. We only started recording stuff from 2018. So this is the course material from 2018. 2019 was a class of first years, and all of those lectures are recorded. Now, the first 3 are done without Zoom because it was pre-corona. And then after that, it's Zoom. And I found that Zoom is much easier to follow the lectures because this was done by one of your classmates, Praneeth. He took like a, not like a handheld on a tripod, a camera, and he recorded it. So it's not so clear and it's not so easy to follow, especially when we're coding. But Zoom is great because you get the screen share and it's awesome. So we have 4 lectures here. And after 4 lectures, these are the technical lectures. After you get done with this, you're pretty much good to code. And then we've got guest lectures from a couple of our students. We've got advanced techniques from Elizabeth, how to publish from Brent, idea to publication from Teddy, and an AI lecture from Roland. So you could kind of go through these as you will. We're going to record these lectures as well, a fresh set. So if you miss something or you want to hear something again, you can always go back and get it. We're recording it live now, and Tahir is he's gonna upload it into right here. I made this file for you, Tahir.
Oh, thank you so much.
Elective course videos.
Thank you.
Okay, and we have the legends and sample code. These are the things that you'll need to really start doing your projects, and the database, of course. So the box is, we're trying to make it like a central location. In the future, we're going to try to make it so that people can upload their projects or ideas. Maybe, ideally we'd have like kind of an interactive thing in the future. Maybe like a website that links to the box where we could get people to talk about stuff. The thing that I'm going to start doing is I go over projects, or I try to mentor students through projects. I'm going to start recording that because I've been doing everything by Zoom. So that will be a good library of stuff as well. So we want to try to make it so that you have access to everything and everything's online. So I think we're kind of on our way to do that. But let me start by giving an introduction to this course. I always give this lecture when I start, and we'll do it here as well. And this is a lecture that I was actually asked to give outside of Baylor, or outside of this course, about how we were able to publish pretty prolifically without funding. And this is really what this course is about. It's about getting you guys to go from idea to publication with just the laptop all on your own, and without any funding. Now, we do need funding for meetings and stuff, and we do get that funding to get you guys to go to meetings. But the whole act of publishing and ideas, we do this without money. And that's one of the reasons that we could do it very easily, that we could do it really fluidly, is that we don't need money. And if you go to the Baylor box, you could look at like the first author. Now, we've published a lot that aren't first author with students, but these are actually first author medical students in the last, I'd say 3-4 years. Yeah. So it's pretty good. And there's more publications, second authors and such, but these are all first author publications. And you could look through them if you're interested. So we've got a track record. We've got a lot of kids through. And so we've developed the skill, I think, the skill set to really get a person to go from idea to publication, all of the skills that are needed along the way, it's sort of independent work. And that's kind of displayed with those papers. Now going to this talk, I think this is a really important way to start. And we'll start with this idea of why this is so powerful. And also then we'll go towards motivation and why even do research, because motivation is a really key aspect to this thing. So funding is really difficult, and it in some ways it really is a barrier for physicians, for students, for everyone to do research, and it's become very difficult to get funding. In this study, only 2% of graduating transplant fellows actually had NIH funding, which is incredible. But we know that funding has become more competitive. The amount of money has been sort of plateaued and maybe even decreasing. The number of applications has been increasing, so the success rate is really difficult. And it's almost like this chicken and the egg type thing, because to get funding, you need to publish, and you need to have a track record, and you need to have preliminary data. Well, how do you do that without money? So that's the power of, I think, being able to code and do your own statistics and deal with database and do the type of research that we do, that we don't need money. Now, it's not to say that you shouldn't get money. I'm writing grants. We've submitted a couple grants, but up to this point, it has been without money. Now, without money, there is no protected time. And that's another thing. And this is not at your stage. I understand at your stage, and we work mostly with medical students. At your stage, it is about getting into residency, and you're not thinking about. But hopefully the skills that we're teaching you are going to be more lasting, and research in general, not just in your particular situation, and when you get out and you're working without money, you don't have protected time, and so it becomes really challenging to do research. And so the first question, and really the most important question, and it starts with you guys, is why and how we're going to teach you, but why to do research, because the motivation is the limiting factor, without a question. And it becomes a limiting factor throughout, when you graduate after residency as an attending. And so the idea of why to do research is really, really key. Now at your stage, it's kind of clear, because it's so competitive to get into residencies nowadays, and they're demanding research from you guys. So there's a strong, concrete motivation to do it. But actually, that's not enough, I find. A lot of times you need to have more that drive you to do it. So, the main reason that, we can think from a sort of a field perspective or from a global perspective is that we have a very important perspective as clinicians and as surgeons, that we need to be able to have a seat at the table. We need to be able to contribute. We can't leave the research just to researchers, because they don't see the things that we see on a daily basis. They don't have the clinical insights that we have. Collaboration is good, but there is a greater level of involvement when the researcher is also the clinician. So it's an important thing. And the idea that surgeon scientists are going to extinction has been talked about and has been circulating in our literature. And here is a interesting editorial in JAMA JAMA Surgery by Kibbe, who's the editor, about this idea. So motivation becomes really important. Now, there's a lot of lower level motivations which are really motivating. I mean, getting into residency, getting tenure if you're a professor, getting promoted, all of these things. But it will drive you to a certain point. But after that, when you get tenure, when you get into residency, what keeps you going? And so higher motivations becomes really, really important. And what you could do with research is amazing. You can have an impact on people. You can have a seat at the table. You can think about your field. You can shape your field, all of those things. And I'll give you a great example. This is a paper that I did that I'm not first author. And it really goes to the credit of my co-resident. I was a resident at Columbia, and this came out, I don't know, maybe like 4 or 5 years after we finished. But, my co-resident came up with this idea of looking at long waiting times before people got transplanted for cancer and how they did. It was really a natural experiment. He published this in Hepatology, and 6 months later, it became national policy to wait 6 months before you transplant someone with cancer, with liver cancer. And it saved so many people from having recurrence. And it's really been an amazing impact. And this was done with what we do. Same thing, the database research. So it can be, you can really make a difference. And we've done stuff where we are looking at low volume pediatric transplant centers and found a lot of problems with some of the outcomes. And, we published on it, and it's gotten a lot of traction. There's been push from UNOS to limit low volume centers in kind of measured ways. But we have agendas, and agendas is not the right word, but we have, missions or things that we want to accomplish and things that we want to better. And you could do that with research. And that's the best motivation. If you get into that, if you tap into that, like you're into it and you're trying to make a difference and you're interested, that's a game changer. That's when you have motivation for life. Now, looking at this cartoon, what we can teach you is to do research, to publish without money. And that really gives you a lot of freedom, because when you're trying to get grants, or you're really kind of constrained by the money flow and getting grants. And you see here before grad school, the student says, I could do whatever, I could research whatever, but when he's in as a grad student, he's got to do what his professor wants to do. And then when you're assistant professor with the tenure committee, and when you become tenured, then you need to keep your grants going. And so, and then by the time you're a professor emeritus, you don't have any time. But without money, you could do whatever you want. You could study whatever you want to do. And we do that. And, I looked at this survey of opioid pills, like left in cabinets, which has nothing to do with my field, but I could study whatever I want, whatever I want to study. I'm not beholden to anyone. I don't have any protected time. I don't have any money. So in some ways, this form of research, almost this kind of like guerrilla form of approaching research, getting students to do research on their own, is really freeing. And it can be, you can accomplish a lot. My story, in brief, how I got to do this, and what my background is I was a resident doing general surgery at Columbia, and there's my mentor at that time was Mark Hardy, and I was supposed to go and do research at UCSF, but that fell through, and then I worked in my own home residency program with Dr. Hardy. But his lab was not really functional. So I really had to teach myself how to code. I taught myself through another resident to do Stata. And I started coding, and this was in 2003 when I started, and 2004, 2003. And my first thing that I did was I came up with this index as a third-year resident, in a very simple index called the soft score. And that's what I'm going to teach you guys. And the class is based on how to actually go and make the soft score, because it teaches you all the fundamentals of what you need to publish. But I was able to do this as a third-year resident. And it's been like, you know, kind of my pinnacle probably of what I'll achieve in terms of, you know, impact. If I look, and this is, I don't mean not to brag, just to show the sort of what is possible with this stuff. And if I have to put score and I can't just put soft, but if I put in the soft score, I mean, this paper is cited 300 times, and it was published in '08. I mean, that 300 times citations is incredible. That's by far the most citations that I've gotten, and this paper will be more highly cited than anything I probably ever write. I don't know if that's true, but and it was done with this work, right? With this simple code that I'm going to teach you, and that's basically what the class is going to be on, the soft code, okay? And then we have developed this sort of kind of research collaborative where we work with all different types of people in our collaborative. That's kind of taken a back seat during Corona, but the class is going, and we've had some students who really take to this stuff, are self-motivated, have done amazing things. Dor here is, you know, graduated, so he's like going into his second year of residency. So that's how long we've been teaching. And he was one of our stars, and he published, I think he's got maybe, we'll look him up on PubMed, you know, but he's gotten, you know, he published maybe 10 times with us, got grants, now is in the University of Colorado, and is really almost leading their clinical research there as a resident. So it was pretty amazing, but we'll look them up. This is a great thing about screen share. I mean, we would have something similar on our lectures before, but so he's got 19 papers already as a second year resident. And then when he was with us, you know, all these papers from 4 to 19, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 papers with us. And then now he's publishing at the University of Colorado, another 8. Just amazing. 19 publications where he's sort of engaged and involved already is phenomenal. But that he's an example of what can be accomplished. And that's his wife, Jordan. She also worked with us as well and did a lot of great things. More with the pediatricians, not so much with the surgeons. She's doing pediatric residency at Colorado. And that's one of the things too, is we could train you and then we could send you out and you could do whatever field you want to do. You don't have to do transplant research or research with us. People tend to do because we have a way of giving them sample projects. We have a support system, but it's not necessary. And Jordan's an example of that. And then we set up kind of this, you know, hierarchy where, you know, we link you up with mentors and we give you projects. Like, I'll give you an example. Going back to the Baylor box. If you go to the static course, we have our projects already divvied out here. And so these are your classmates here. There's one Rice student, but these are your classmates who are on the Divya. I forgot Divya, Gaibo, Wesley, they all have projects here, and they have mentors. And we're gonna do that. So you have a student, and then you have a mentor, and then you have me, of course, and then you have the project. So that's kind of the way we set it up, so that you have support. And also, as a class, people tend to work together. Luckily, your class has a lot of people already, right? All those people. So, you know, as you guys get through, you can work with them. And we used to have a research meeting where we served lunch and we went over everyone's projects. But so this wasn't just 2018. I know I showed that Baylor Box has the papers. And again, this is not to brag, but just to show what can be accomplished. In 2018, our group had 27 papers, 11 first authors from 7 different medical students in 2018. I have to look at the 2019 numbers. I don't. But how is this done? It's really, I can tell you from experience, it's done when people get motivated, they get into it. And if you get into it, that's awesome. And then you could use that fuel to really drive you. And Tahar is a great example of that as well. I mean, I don't know how many papers you're going to end up with, Tahar. You have you probably end up with 5, 6 papers, I bet.
Yeah,
Tahar is also
so.
one of those guys who kind of got into it. He got into the research and the power of doing the research. And when you get that, you get it. And if you don't get it, that's okay. You don't, there's no obligation in this course, which is kind of one of the great things about the course, is that you could do it. And if you don't like it or you could drop out, because we have a lot of students. And so we don't expect everyone to take a project to completion. And then people sometimes will work and then they get busy with school, because school is first priority. And that's fine too. You could work on a project, break, come back to it. It's really flexible. It's not a one-on-one mentoring, because it's just me. I have some of my partners, but they're not really into this research. But there's just me, and then there's a bunch of students who've been trained. So there's not a one-on-one kind of mentorship, which is the downside. But the positive side is that I found that anyone who wants the help gets the help, and there's no obligation. So it's kind of perfectly tailored for medical students, especially during the first and second years. Because by the time you get to third year, it becomes really hard. And, we see that and we know that and we understand that. So that's all there. It's not easy to publish either. I mean, there's a lot of kids who publish, but it takes a long time to publish. It takes, submission, and Tara can tell you this. And we've actually have a guest lecture you should see by, the guest lecture by, Brent, who went through his saga of getting a paper published, and it went to a great journal, went to pediatric surgery, but the saga, it's there, and the revisions and the time, it's a hard thing to get through. So you have to be motivated. You have to figure out what you're motivated, and if you're not motivated, it's okay. So that's kind of the benefit of this, but it takes a lot. I mean, I'll teach you the background, the ability to do it, and we'll give you the support. But you got to kind of go through the reps and figure out the stuff. Not figure out on your own, but you have to put the boots on the ground type thing to get this. And it's time consuming. And Tahar is right here, which is perfect, because we have someone, who. And would you agree about that, or could you speak to that?
Yeah. So I think what I'll say is, I think a lot of students do actually go through and they are able to publish. I actually just submitted a paper with Dr. Anna to the American Journal of Transplant. And I think that if you guys the one thing I wish I could go back and do differently is I wish I had a much better handle on my class load. If you guys have a strong handle on your class load and you just knock that out, you will have so much time to publish with this group, with Dr. Anna. You guys are first years right now, almost second years. You'll have 2 years. I think you guys could easily work on 5 or 6 projects, one at a time, and submit them to journals and get them published. It does take time. Getting USIS data takes a little bit of time. And then what I will say is you just have to sit down and go through the code, and you become pretty good at figuring out how to work Stata, and then to also figuring out how to automate certain processes within Stata as well. So, yeah.
And the other thing, so we are surgeons. We're all my group and myself, my group. We're all busy clinical surgeons. So we also, in addition to doing research, we can help you with letters for residency, mentoring for residency, because we've got a lot of students who've come through. Our program, not just my class, but working with Dr. Goss, who's our chief before, so there's that. And, a lot of our students have matched well. We've had great matches and those sorts of things. And 2 of my partners went through Baylor Medical School as well as Baylor residency in our faculty now. So they're great resources as well. So that's another aspect to this. We give you letters. We give you access to the transplant department if you're interested in surgery. And if you're not interested in surgery, and we have one of our star students, Teddy, is not interested in doing general surgery, wants to do orthopedic surgery, but he's publish it. And, you know, we asked you, well, why do you want to publish with us? He says it doesn't matter for ortho. I don't know. It may differ for what field you're going into, but he says it doesn't matter. It's just publications. So there's that. Going back to the lecture, we have to, you know, one of the magical aspects of this, and I've found, is that we handle the data ourselves. And when you handle the data yourself, you can get so much insight into what's going on. And that's been the secret of us being so prolific, coming up with so many ideas, is that I handle the data, we handle the data ourselves. And in the long term, clinicians should always handle the data, because you could hypothesis test, you could hypothesis test in real time over and over again. You can get insights in the data. Handling the data is really the magic here. And, you know, we do this with Stata. And then, you know, no mountain too high. We've had like amazing papers that we've been able to publish. One paper by Elizabeth Godfrey, who's another STAR student, looked at questioning MELD, the MELD score. As a medical student, we questioned the MELD score, and we wrote it to the American Journal of Transplantation, our main journal, and it challenged the MELD score. And the MELD originator, you know, wrote a letter, you know, trying to defend the MELD score, and we wrote a counter letter, and it was all sort of the statistical warfare, you know, like statistical methods. And Elizabeth was able to take the basics of this and be able to respond to almost the highest level of statistics, which was amazing. So what can be accomplished is, there's no doubt, as med students, what can be accomplished. I mean, we've had papers in pediatrics, we've had papers in JAMA cardiology, we're going to get one in JAMA surgery. So really high level papers, you know, we're able to get in. Not always, a lot of them are low level papers, but you know, there are some that are great. And so, you know, that's kind of been the thing, you know, is, you know, you have to manage your emotions. You need to know why you're doing it. It's really the most important thing. You have to handle the data. And then this is for other transplant surgeons, but you use your EBS. You know, you're busy sometimes, you have exams, you shut research down. And when it's slow, then you pick it up. I mean, a lot of people picked up doing a lot of research when they got, you know, they got sent home for the corona. You know, a lot of people did. So you could do that, and you have that flexibility. So that's the lecture that I tend to give to start off with. Now, does anyone have any questions so far? None up to this point? Okay. All right, so now we're gonna go to the interface. Now the interface is really important. The Stata interface is really important, and here it is. And it's really important because we code. We always code. Now there's drop-down menus. You see I could drop down any of these statistical tests here. There's drop-down menus you could do for any statistical program. There's SPSS, there's Stata, but we do not do drop-downs. And the reason for that is I think you'll find that when you code, it's incredibly more efficient. And you can handle the data so much more, it's almost granular and tangible the way you handle the data. So we code. The other thing, it's transferable. I could write code, you could take my code, I could send you my code. And if you go to the Baylor box, that's another reason why I think people are pretty successful at publishing in this course, is because there's so much sample code. Look, you just hit sample code and you got all this code. And so there's 12 pages to this. You see 12 pages of code, all sorts of code that I've been writing and people have been writing, and then you could search it. And I'm going to organize the code. I know that's one of the things that I want to do, and I will do, is make it so it's organized, specific things that, you know, you could look up. But there's so much sample code. And for example, if you open this, you see all this sample code. This looks like gibberish to you, but you'll understand it. But you could, so that's just one code, right? All that stuff. There's hundreds of pieces of code in this, in the Stata, in the Stata course box, there is hundreds of codes, and then online, there's hundreds of codes. But this is code specifically for our database with our projects, so it becomes incredibly useful. Would you agree, Tahir? Do you want to speak to that?
Yeah, I think it becomes useful. I think one of the things that we're trying to push for is, as people are writing their code, to comment. That way that like whenever like someone fresh comes and like looks at the code, they're able to understand like the thought process behind like what was going on. So like that's something that, like, for the three of you who are taking this class, like, you know, as you're working on your code, like, we're gonna talk about like what is good commenting, what is good like code writing, so that like when you guys will be the gold standard probably, you know, like as we move forward with like the coding and stuff. Is that fair, Dr. Anna?
Yeah. So, and we're going to organize it more and more.
Yeah.
People give, you know, be able to upload their own code for their own projects.
Yeah.
And, you know, we envision it to be more of an interactive thing. So
Yeah.
should be pretty interesting.
What
Uh-huh.
I was gonna say, what I can say is, like, on the paper that I wrote with Dr. Anna, the reason I was able to get so far so fast was because I had Dr. Anna's code as like my base.
Yeah.
So I was able to take that and adapt it, and that like was very, very helpful.
And everyone does it. Everyone takes code and they adapt it. So that's why it works, and it's easier to work. And especially your first projects, we tend to give you stuff that can be adapted easily. Okay. Now, for this class in particular, we are not gonna, you know, it's basically pass, not pass. There's no grades to this, and just participation. I mean, if you show up and you watch the lectures, you're involved. I mean, I'm not gonna be tough on the grading, and you don't have to complete a project. You know, we'd like to see you do something, but you don't have to. So if you get to it and you feel it's not for you, you know, you could talk to me, you can drop out, or you could, you know, continue it on and not do a project. We have every option available there. Okay, so to start off with, the first thing that we want you to do is we need you to get a look at the soft code, at the soft score. And this is that paper that I pulled up on Google, with the citations. And I want you to read, as your first assignment, to read this maybe 3 or 4 times. It may not make sense, but you're going to read. This is what the class is designed. I'm going to take you, we're going to basically learn how to do this, make this paper. But the idea, the way the paper is written, the methods, the results, it doesn't change that much. Okay, so really read it, and that's what this is. This is what I could. Now, you could spin it off in 100 ways. It's amazing how you could spin it off, but this is the basic aspect of it. So that's the first thing. Now, Tar, we need to make sure we add this to the box. I thought it was in the box. I tried to organize it ahead of time, but
You're talking about the
soft score.
The soft score's not in there.
Yeah.
Because I see the folder.
Yeah, I'll add it. We're gonna add it right here. I'll add it up. I'll upload it right here. The lecture that I just gave, the PowerPoint and the actual soft score, we're gonna upload to this, so you can get it. I think it may be under first. No, these are first.
No, this is students.
Yeah. Okay. All right. Well, anyways, we're gonna get that. So the first thing I want you to do is read over it 4 or 5 times. The next thing I want you to do is I'm going to want you to look at this data. And here, give me a second here. Okay, so let me just try to get some of this out so it's not so confusing. Okay, so this data, and this is the interface that we use. And what this allows you to do, Stata, it allows you to run statistical analyses and to handle a large database. The database that we're using is the liver transplant database for the US experience. It's called the OPTN database. This database is based on regulation, based on a an act passed by Congress, the National Organ Transplant Act, in the 1980s, in the mid 80s, and they said that every transplant program has to supply data on outcomes because it needed to be regulated. It was such a new field. It really became a field in the mid 80s. So it's really new. It needed to be regulated. And all of that regulatory data is what we do research on. And it's actually can be quite good in certain respects and not good in other respects. So that is our database. And this database, if I do some patient code is a unique identifier, has 279,000 patients. It's incredibly large. It is essentially an Excel sheet. You see this Excel sheet here? This is just an incredible Excel sheet with 300 variables, and you go all the way down, 300,000 entries. And every database is essentially a Excel sheet, right? Just incredibly large. We are going to be able to manipulate and look at this data and, and basically explore this data with code. So it's not a direct actually looking at the actual Excel sheet, but with the code, we can really maneuver and understand this data. So it's 279,000 patients. The first step, so you have two homework assignments. One is to read the soft score over and over again. And for tomorrow's class, Tahar, are we going to really do tomorrow's class? Do you want to, because everyone doesn't have stata, because I'll need people to have stata by tomorrow's class.
Well, Dr. Anna, what do you feel about doing 3 lectures next week? I think, so I think that might be the move then. If that's okay with all of y'all. Is that okay?
Yeah.
All right.
Yeah, sure. And as you know from this actual class today, you have to be flexible because my schedule is very erratic. And that's in general. We can cancel classes for you guys too. It's kind of a two-way street. You guys have something come up or don't want to have class. You guys can cancel. I can cancel class, but we have to be flexible. But ideally with Zoom, it becomes like no issue because everything's recorded and it's just, you can go ahead and get it. So you will have stata on your computer. Read the soft score. When you get the stata on your computer, I want you to go through the variables. The variables or the covariates, the variables right here along the side here, that is the art of any analysis of any database. You have to understand the variables. It's all it is. The code is, you could cut and paste. The analysis you could look up. It's just like tedious, just code. But the art is the variables. And I can't stress that enough. It's all about the variables. So you need to start going through these variables. And
yeah, it's painful at first because you guys are all fresh to this, but the better job you do of building your foundations, you'll get faster and faster and faster at this. And that's when you guys will be able to generate your own ideas as well. And you'll move through this. You'll be like little rabbits. It'll be good.
So the first thing I want to do is I want to alphabetize these variables, and that's A order. That's the code. It's really important to alphabetize because I want to keep these variables in my head. I want to start to know these variables. My expertise in this database is for the past, 15 years, right? I've been doing this. So 15 years with this database. My expertise is understanding these variables. That's it. Knowing what is a good variable, what has good entry completion, what's accurate, what you could study from a variable, and understanding these 300 variables. And all of my expertise lies in that understanding. So you need to start to understand it. And whatever database you do, if it's not the OPTN database, it's CMS or whatever you're doing, you need to understand the variables. And you got to keep them in your mind. So the best way, the first thing to do is alphabetize. You alphabetize the entire thing. Now, when you get a variable, the first thing you want to do is you want to go ahead and if you click on it, you'll get the basic properties. There's two types of variables. There's categorical and continuous, and they're treated differently. Categorical is like a color, blue, yellow, red. a very distinct designation, only a certain number of options. Continuous is a scale. It's like age, 0 to 80, or creatinine from 1 to, you know, whatever. It's a continuous scale. So continuous and categorical, two different types of variables, and they have different languages, and they're treated differently, and you have to treat them differently. And so this will tell you a lot about what's going on. Here, there's 399 variables in the entire database, right? Here, there's 279,000 entries. This is the size of the memory. And so another way of doing this is you click on the data manager or the editor, data browser, or data editor, either one. You click on it, and if you click on this, you could actually look at the label. And here you have to pull it out, and this will give you insight into what the variable is. It's coded ABO. This is the ABO blood group. Here, you actually look at the actual data, and you should always look at that data, like what is the actual data in the Excel sheet, the ABO. So the first thing you do is you do that. The next thing you can always do is you can always cross-reference the legend. Sometimes they will be, like for example, they will be coded numbers for a variable, and you need to look at the legend to see what they mean. We'll come to that in 1 second. But let me start with ABO. We'll start from the top. ABO, so we looked at it, we looked at the data editor, we see its blood group. The first thing I'm going to do is tabulate ABO. Tabulate is what you use for categorical, and it turns out ABO is a categorical variable, and it has these specific blood types. So I learn how the different types of blood types are designated. It's not just A, there's A1, but it looks like it's not really completed very well, A1. So probably most of the A1s are being lumped into A. These are the types of things that I understand by looking at this variable. The other thing I know is that if you look at this, there's 279,000 entries. There's 279,000 people in this database. This is a really highly coded. The entry completion rate is 100%. So that tells me something about the accuracy of this variable and whether or not it could be used. Out of the 399 variables, I bet you can use maybe only 99. The rest are just not entered appropriately. And that's true with any database. And so you need to, that's what, when I say the art, you got to know which ones are good and which ones aren't. This is a good variable. And unknown is only 2. Now, why is it a good variable? Because blood type is so important in transplant, right? You have to have compatible blood type. A has to go to A, or A has to go to O. Blood type is incredibly important. So that has to be put in, and it is, because this is a regulatory database by its nature. And so tabulate is, you can shorten it to tab, is what you use for categorical. Summarize, or sum, is what you use for continuous variables. So let's sum age. So I summarize age, and it turns out that you look at this, the mean is 47. That's entire US transplant experience. The average age was 47. The standard deviation is 18. Maximum age is 84. 156,000 entries. Now, 156,000 entries, but there's 279,000 patients, right? So what is that entry completion rate? This display is a way of doing a simple, like, mathematical equation. 55%. So that's not very good. Now it turns out, and the only way you'll know this is by going through the variables. It turns out that this is the age at transplant, but not everyone gets transplanted. In fact, this is a database of everyone who gets listed for transplant. So there are 279,000 people who got listed, but only 156,000 who got transplanted. So about half the people get transplanted who get listed. The other half die waiting for transplant. So this is a variable that is at the time point of transplant. So that's why it's only 156,000. I know that from my past experience. If you tabulate age, you can tabulate age, and it won't work if there's like, if you're like 27.23 years, but it does work if it's even numbers. And the way the database here is it just does it by integer. And so here you can see all of the ages. And this is indeed at the time of transplant. So to understand these, now there's something else called init age, which is initial age. And this is the age where we are, hold on one second. They're just texting me about that lap chole. Okay, all right, good, perfect timing. So this is the age at listing. So this has a great entry completion rate. Age is something that has to be good. It has to be, because it's such a fundamental thing. So it has to have a high accuracy. And so here you can see the two different variables, age and init age, are totally different. And they designate different things, and they explain the whole picture. Init age is the time at listing. Initial age it stands for. And age is time at transplant. And these are the two time points in this database, listing and transplant. And each one has different variables. So it's really, there's really only two in this database. That's the important thing that you need to understand, is the time points when you're looking at a database. And these are the two time points. So there you learn so much. We learned so much by just going through two variables, right? And then you have to keep going through all of them. There's 399, you should go through all of them. The next one, we're going to tabulate ABO donor, and this is the donor. And see 156, that 156 comes up again. 156,000 are donors who actually got donors used in transplant. So that's where that number comes from, and that number comes from. And this is the way the donors are broken up. And then you go through and you go through them all. Now, if you summarize a categorical, because summarize is used for continuous, nothing will come up. You have to tabulate categoricals, summarize continuous. Now, for example, I tabulated age, but if I tabulate creatinine donor, for example, it's gonna, I mean, it'll give you all of them, but it'll go on for, you know, it'll just keep going on. So, okay, so that needs to be gone through. Now, if we get to our third one, we'll tab ABO math. This is ABO match level, and it's 1, 2, 3. You have no idea what 1, 2, 3 means. And this happens with a lot of variables. You have no idea. In that case, what you have to do is you have to go to the legends. And here we go, legends, and it's on your thing. Let me see if it will let me download it. It's not letting me download it, so I can't search it, but here I'll pull up this one. And so I want to go ABO. I just search ABO, and then that didn't work. So I could go ABO math. And sometimes you have to look, how many years have I been doing this? And I'm like looking for this. I know what it means. I know what 1, 2, 3 means, but it's not coming up there. And that's a liver thing. Let me see if
Is there that Excel sheet, that master Excel sheet, Dr. Anna? Is it in there maybe?
What's that? Let me see if I can download this thing. No, it should be in there. I'm not sure why it's not on. Sometimes there are quirks, because sometimes it's like an old data, it's like an old legend or not, but let me download it from the box and then I can manipulate this. I'm sure this will have it. This is the full legend here. I'm not even sure. Are you able to download stuff off the box?
Yeah, I just downloaded the file that you're trying to download right now.
I just
Yeah.
opened it. I'll just download it like this. There it is.
Yeah.
Okay, so ABO, let's see, Matt. ABO. See, here it is. ABO
Oh, wow.
Matt. You see this? So it's 1 is identical, 2 is compatible, 3 is incompatible.
Huh.
So I go to this database, and now I understand what 1, 2, and 3 means. It's very common that you'll have this, but you can find anything in the legend. Just search it. It's not really that hard to do. Okay, so you want to go through and look. Now, if I go to the next one, tabulate, and you can click on it too, so you don't have to type it out. This is academic activity level. Academic activity level. And if I click on it, I see that there's only 12,000 entries. And this is like almost a useless thing. Because if we have 300,000 pages, 12,000 entries, what can you use it for? Can't use it for much at all. So it's really hard to use this variable. You can't use it, really. I'll give you another example. And there's controlled. This is donor if it's a controlled death donor, which means it's a donation after cardiac death. It's a specific type of donor that we do. There's 4,800 out of 300,000 patients. You'd think it's a useless variable. But this is a specific type of variable that we know that is entered if it happens, and is not and nothing is entered if it doesn't happen, because it's very rare. Like if someone gets a DCD, it's called a DCD, the short term, that organ, they're going to definitely put it into the database because they get risk credit in regulation for it. But it's done so uncommonly that if they don't do it, they don't even think about it. Another example is a live donation, a living donation. When someone gives a living donation, you're going to record it. But if you don't, you're going to leave it blank. This is a rare instance, and there's a couple of them, and we know from experience which ones they are, that you could use it because you assume that if it happens, that it would be coded. And it's a safe assumption in certain circumstances, but not with this one. So this is a bad variable. And then, well, what does it mean? Let's go back to the legend. I tend to control F everything, you know? So right here, academic level. 1 means full load, 2, reduced load. See? 96 is less than 5 years of high school, and 98 is unknown. So you have this legend based on that. Okay? Okay, guys, so this is all it is to start off with. Read the soft score, understand all of these variables. Okay?
So I think a question might be like with this academic activity level variable, it's listed differently in this data than it is in the legend. Like you looked at ACAD level, right? So are they going to run into that where some of the variables are abbreviated in the legend?
Yes. Well, so you know, there's this database comes out every 6 months, and it changes, unfortunately. So most of the code works, but sometimes you'll have to tweak the code a little bit. That's one of the issues, is that they will change it. It's like an updated version of Windows, and they change everything slightly. So you get, it's not completely smooth sailing. Yeah, but the changes are minor, you know, as you can see. And people really don't complain about it too much, the minor changes. But sometimes you want to cut and paste a bunch of code and it doesn't run properly, and you have to go in and fix it. It'll take you 15, 20 minutes to fix, but you guys still have to do it. Okay? Anything else, guys? No? Any questions so far?
So are we, just to clarify, class has been moved to next week instead of tomorrow?
Yeah, I'll send out
Okay,
a Wendy meet today, so you guys can. I know your schedules might be changing, and so we'll schedule 3 one-hour sessions next week over Zoom.
Awesome, thanks.
Yeah.
I guess just regarding getting Stata, we tried downloading it from the box. I've tried various things. Nothing seemed to work yet.
I don't think it's on the box, is it? I don't think Stata is on the box.
Well,
No.
we like it was like we tried to go to the box, like upload it to a box and download it so we could transfer it to someone who doesn't have it.
Oh, well,
Yeah.
you know, STAT is a licensed thing, so I know there's something circulating out there, but I don't know if you can just upload it to the box. Now it's not being recorded.
Yeah.
Right?
Yeah,
why
we're being recorded. State has a licensed program.
Yeah.
You
Yeah.
should definitely buy it. There's a $48 subscription for 6 months. And if you have other technical issues, I'm happy to talk to you about it after the recorded Zoom lecture. Yeah?
Okay.
Okay. Any other issues?
What's that? Any other?
Yeah, any other issues? Fill out when I send the when to meet, filled out with the weekend too. I'll try to host like an hour or 2 hour like TA sessions so you guys can like come to me like with questions and stuff. And then like, you know, if I'm not able to answer them, I'm sure Dr. Anna will be able to answer them. So
Yeah.
we'll
I
try
generally
it that
don't
way.
work on weekends personally, but
Okay.
what you do is just record it. I mean, I work for work on weekends.
Yeah.
For these dang transplants, but not for other things.
Yeah,
So,
makes sense.
Yeah, just go ahead and record whatever you do, Tara.
Yeah, it'll be recorded. All right.
Awesome.
Okay.
Any questions? Anything else? Do you have any questions? No, Malcolm, any questions? No?
Yeah.
Okay. Now, if you guys, not for you, anytime you can drop out. I don't know about the grading. I don't know what will happen with it. But we have to work that out if you can drop the course. And now it's credit. Before it was all informal, you know, because there's no credit. This is the first time we're doing credit. So I don't know if it's a good thing or not. I think it's a good thing, right?
I think it'll encourage more people to do it.
CV. You know, you can put it on your CV and you get an actual thing you can put on your CV, you know, which will be cool.
Yeah.
And especially if you publish, you know, you publish something, you have it on your CV, a class, it's like another line in your CV. And then the other thing briefly is that to maximize the lines on your CV. So you have a project, you should present it. You could present it in the Baylor thing, a national meeting, and then you publish it.
Yeah.
Three.
I think I've taken the same one project, and I've gone and presented at 2 different national meetings. And like the way I did that was I focused on different aspects of that project. Once you have like your code, you have like a baby, and like you can like turn that thing and like go in different directions. So.
Yeah. So I mean that stuff. I mean that is really an important thing. I mean, these are practical. I was just talking about the higher motivations, but these are practical aspects to this whole thing. So yeah, you want to do that. I encourage you guys to put each other on your papers. Help each other. Put yourselves on each other's papers because it just maximizes papers. Like if you 3, you know, do that for each other. And I'm not saying that you gift authorship. I mean, you help them. Check someone's code. I have a couple people who are now having projects that are finished, and I'd say, okay, well, have someone check your code, and then add them to the paper, you know, and you really encourage that, and like a team aspect to it. And then every class tends to have this. They run things by each other, and that you should be no different. Your class should be no different, and you have other people. You'll have 2nd years, 3rd years, 4th years to run stuff by. Okay, sound good? All right, awesome. Great first class. Please read the soft score, go over the variables, and then next week we'll start coding. We'll get into the weeds next week. Okay.
Does everyone have access to the box? This is just technical.
I saw Greta join. I had them all join.
Okay, great, perfect.
All right, awesome. Okay, guys, thanks so much.
Thank you.
Thank you. Take care. Bye bye.
Thank you.
Bye bye. Stop this recording.